And we should be on the air. Welcome to the Planetary Society's special coverage of a milestone for humanity's first mission to Pluto. I'm Matt Kaplan, the host of Planetary Radio, coming to you live from Planetary Society headquarters in Pasadena, California. We'll be with you for the next hour or so with this very informal webcast as the world waits for word from the New Horizons spacecraft that it has successfully roused itself from hibernation. And this is the last time it's going to have to do that. It stays on now right through its encounter with Pluto, which is coming up very, very soon, as you will shortly hear. That communication from the spacecraft is expected as early as 30 minutes past the hour. So we're a little bit less than 30 minutes from now, although there may be some factors that will get in the way. And we'll keep track of that as we get into it. There are some weather factors, as you'll hear, that might interfere. While we wait, though, we have four absolutely outstanding guests who are going to be joining us, beginning with this special guest, who is the only one to actually join me live here in the studio. We are absolutely thrilled to have Bonnie Barati join us here. Bonnie is a principal scientist, senior research scientist at the Jet Propulsion Lab, very close to where we are now in Pasadena. She supervises the Asteroids, Comets, and Satellites group. She's been a JPLer for nearly 30 years, working on an impressive array of past and current missions, including Deep Space One, Voyager, Cassini, and Dawn. And she studies the outer solar system, so it's a particularly appropriate mission, isn't it?
Yeah.
Icy moons. And you might want to check out a video about her. I don't know how old that is, the Through the Eyes of the Scientist.
It's just a couple years old.
Yeah, it's part of a very good series, but I very much enjoyed your contribution to it.
Thank you.
Welcome, Bonnie.
Yes, good to be here.
I'm glad to have you. You have, as we just said, worked on so many missions. What sets New Horizons apart?
Well, New Horizons is the first time we're going to see what we call the third zone. We've visited the terrestrial planets, Mercury, Venus, Earth, and Mars. We've seen the gaseous planets pretty close up, Jupiter, Saturn, Uranus, Neptune. But this is the first time we're going to be in what we call the third zone of these icy bodies in the outer solar system. And Pluto is, I think, probably the most amazing. It's got 5 moons, it's got an atmosphere, it has seasons. So this is what makes it so thrilling to be part of the New Horizons mission.
What are you hoping to learn? Someone who studies icy moons, studies the surface of these bodies?
I think the number one thing I'm interested in is whether Pluto is active or not. Does it have some active geology? You know, on the Cassini mission, probably the most exciting thing was that we discovered these huge plumes on Enceladus, this icy moon of Saturn. And I don't think we'll see anything that big on Pluto, but maybe we'll see something like the little plumes we saw on Triton, which is a large moon of Neptune. It has a polar cap, and there were these gaseous plumes coming off of the polar cap. Maybe we'll see something like that. Maybe we'll see something even bigger. So I think that's the most interesting thing we will learn, whether or not Pluto is currently geologically active.
The implication here, as probably most of our audience already knows, is that we really don't know a whole lot about Pluto and Charon and all those other little bodies out there.
This is very true. We kind of know their size. We've been able to measure an atmosphere, which is changing, by the way. It's about double the pressure it was just 15 years ago. We know a little bit about the surface composition. It's got nitrogen and carbon dioxide and carbon monoxide and water ice. We can see those things, methane, but we don't really know what the surface looks like. Are we going to see, how many craters are we going to see? How many mountains are we going to see? Are there going to be big faults on the surface? You know, what kind of strange thing? Because every time we've gone to a new object, we've seen something different. We just can't predict it.
You know what? It just occurred to me that we do know more about Pluto than we know about exoplanets at the moment. But it is kind of similar in that we, as you said, we can't see the surface. We're about to. I mean, is that a decent comparison?
I think so, yeah. I think that, that's actually, I think that that's a good analogy because exoplanets we see just as, not even as pinpoints of light, they're just little things we infer about their composition. We have found methane on an exoplanet. And Pluto, we've been studying it just as a little pinpoint of light. We've just, been looking at spatial variations on it just by watching it rotate, seeing some differences on the surface. But I mean, I've seen, looked at it many times in a telescope. You have to have a fairly large telescope to see it, and just you can't really distinguish it from the stars. We get some little bit of resolution with a Hubble Space Telescope, but it's only really very, very rough. So yeah, that's a good analogy.
Hubble is going to come up in the next segment that we're going to be going to in just a couple of moments here.
Okay.
I said we've got 4 people. Bonnie, the only person who is actually here with us this evening. But we're going to hear from Alan Stern in a moment. Alan Stern, I sometimes call him the busiest man in the solar system. He is the principal investigator, the guy in charge of the New Horizons mission. We recorded a special conversation with him via Skype about 2 days ago. Alan is extremely busy, as you might imagine, tonight at the Johns Hopkins University Mission Operations Center. So we won't be talking to him live this evening, but later tonight, we do hope to connect with Hal Weaver, who is the project scientist for New Horizons. We hope that'll happen after we have gotten the confirmation from New Horizons that it indeed has woken up for the last time. And then we have one other guest that we'll be going to right after we hear from Alan, and that's Felicia Sanders, based, like Bonnie, at JPL, where they operate the Deep Space Network. And Felicia has essentially been the liaison, I guess, with the New Horizons mission.
Right, this is true. Yeah, I mean, it's really complicated to try to schedule time with the Deep Space Network, and there's just a lot of intricacies. So she has been, kind of heading that up.
No small task to communicate with something 30 billion, 30 AU, 31 or AU away, I think now?
Yeah.
Something like that. All right, I think we've reached the point where we can go ahead and start that Alan Stern conversation. It's a little bit rough. It was done with Alan in his hotel room in Germany with typical hotel bandwidth for doing Skype. So it's a little fuzzy, but I think you'll enjoy it. I certainly enjoyed talking to him, as I always do. Now, this is a one-man band here. I'm kind of running things on my own today, but with any luck, in just a moment, we will be able to bring that up for you. I have to click here and over, let me see here. I've got to click right here, as a matter of fact. So let's go to that conversation recorded a couple of days ago with Alan Stern about New Horizons. Alan, thanks so much for joining us on this very special evening. Of course, as you and I speak, there's still, barely 2 days before the big wake-up call takes place. Where do we find you?
I'm in Germany for a Rosetta Science Team meeting.
2 days before this big thing happens. And when that happens, you'll be back at JHU, the Applied Physics Laboratory, right? Right in the thick of things.
That's right. I'm flying home, actually flying back to DC tomorrow night on Friday, and then we'll be at Hopkins in the Mission Operations Control Center on Saturday.
Now, as people see this, there will be only minutes, maybe seconds to go before we get that phone home from New Horizons. What do you expect to be doing there at that time, other than biting your nails?
I'm growing them long just for this occasion.
Good work. Preparation.
Well, as you know, New Horizons has really pioneered the hibernation technique. It saves wear and tear on the spacecraft, and it reduces our mission operations costs because our mission operations control team, our science planning team, don't have to babysit the spacecraft for 9 straight years. While the spacecraft is hibernating, they can be planning Pluto encounter, and that's how we've kept our team down in the dozens of people, whereas Voyager was up north of 400 to plan their encounters. So the spacecraft has been in hibernation a lot. In fact, this final wake up is our 18th time we've emerged from hibernation. So I'm really not expecting very much nail biting.
That's good. What can we expect? What do we expect to hear from the spacecraft when the magic moment comes?
Well, let me start with a little bit of timeline for you. Out there, 3 billion miles away, close to Pluto, is a little spacecraft speeding ahead at a speed that's so fast it goes from LA to New York City about every 5 minutes, 24/7, and has been doing that since January of 2006. On board the spacecraft is a sequence that's currently operating in what we call passive spin hibernation mode. The spacecraft is looking at the clock about once a second and asking what's next on its to-do list, what we call a command sequence load. When it gets to be the right time on Saturday afternoon, way out there in the Kuiper Belt, the spacecraft will say, the next thing on my to-do list is to wake up from hibernation. And then it will execute a series of commands internally that turn on various avionics, or rather electronics boxes on board, like the guidance system, like some additional heaters, and others. And then after making some other changes on board that bring it out of hibernation mode, another time command will go off and cause it to communicate with us and send a report saying, I'm out of hibernation and here's my health status, and start downloading that. Now that signal will take 4.5 hours almost to reach the ground, even at the speed of light. So by the time that the spacecraft goes through all those steps and then the signal gets down to the deep space network, it's going to be early evening on the East Coast, somewhere around between 9:30 and 10 p.m. on the East Coast, 3 hours earlier out in LA where you are. Now, we don't know exactly when that's going to occur because we don't know when the big antennas in the DSN are going to be able to lock up on the signal. The spacecraft will be very low on the horizon initially, and sometimes they can lock up right away, and sometimes it can take even a couple of tens of minutes, depending upon things like the weather at the DSN station. So we don't know to the moment when we're going to receive word, but it's going to be in the vicinity of 9:30, 10 o'clock Eastern time. And then over the course of several hours, because the bit rate is very low initially, we'll be getting that long health and status report.
I heard you, speaking of a low bit rate, that it's only going to be maybe, 10 bits per second initially?
Well, when the spacecraft's in hibernation mode, it is transmitting at only 10 bits per second. Later, once we put up an operational load, we'll command it to much higher bit rates. We can communicate between 1 and several thousand bits per second by command. And we'll get the bit rates up because that makes things a lot easier in terms of the back and forth.
For the few people watching this webcast, as we are quickly approaching that moment when those bits, more of those bits will be arriving to tell us that New Horizons is awake, review for us what New Horizons hopes to do at Pluto. What mysteries do you hope to throw light on?
Well, I'm not so sure I know what mysteries we're going to throw light on, but what I can tell you is we're going to conduct one gangbuster reconnaissance of the Pluto system. Beginning in January and extending all the way through July, this spacecraft, with the most sophisticated payload ever sent on a first reconnaissance mission, is going to be training those guns, those cameras and spectrometers, the plasma sensors, the dust sensors, radio science, on the Pluto system. Initially, from very far away, it'll just be a dot growing brighter and brighter with little satellites going around. And then we'll get to a point we call BTH. Everything is an acronym. BTH stands for Better Than Hubble. And that means we'll be
I love it.
We'll be getting the best images ever beginning in early May. And they get better and better and better and better all the way through May, June, and July. By the time we reach Pluto, closest approach on July the 14th, the very best images would be something like 70 to 90 meters per pixel. And just to put that in perspective, no Mars mission accomplished that in the 1960s when we did the first 4 Mars missions. It took until the Viking era for us to get that good. So we're going to have tremendous detail on this system, not just Pluto, but also the satellites as well.
And of course, we're all looking forward to the closest approach to Pluto and that whole system out there on July 14th of 2015. But the mission's hardly over at that point, right? You've got lots more observing to do as you leave the vicinity.
Well, we will be making observations. That's absolutely right. For several weeks as we recede from the system, we'll be looking back because we can see the night side, which you can never see from the Earth. You can look at what we call high phase angles in order to make very sensitive searches for rings. and to study the microphysical properties of the surfaces of Pluto and its satellites to look for hazes in the atmosphere with better capability than we can on approach, and to make other kinds of measurements in the Pluto environment, including dust and plasma, things like that. So that'll continue through July, possibly the very beginning of August. And then the spacecraft will take a break, and we'll let our ground team take a break from about 7 months of round the clock. And then beginning in late September, we'll start to download systematically all of the data that's been aboard. And that will take over a year.
And even then, of course, it's not over. Talk about the great news that you got not long ago about what could be another destination for New Horizons.
Well, thanks for asking. That's right. When this mission was conceived by the National Academy of Sciences and its science definition team, and even when NASA put the call for proposals out, in all those instances, it was called Kuiper Belt Pluto, meaning that in addition to reconnoitering the Pluto system, the Academy, the science definition team, and the agency wanted us to be able to go on, to have the capability to fly farther and encounter small protoplanets, small Kuiper Belt objects, about 1,000 times the mass of the Rosetta comet, that are the intermediaries between comets as leftover debris from solar system formation and planets like Pluto and Eris and Makemake. So in fact, using the Hubble Space Telescope, we've now got 2 solid candidates as options to fly by in either late 2018 or early 2019, about 1 billion kilometers beyond Pluto. After we get the Pluto encounter done, we'll work with NASA headquarters and choose between those 2 targets which one is the better one to go after, and we'll make engine maneuvers next fall. But that doesn't guarantee that we'll be able to do the flyby. We still have to get the funding for it, and that will require that we write a proposal, which NASA will evaluate in 2016. And if that goes well, then we'll be authorized to extend our mission to make those actual flybys. And that would be spectacular.
It sure would, and I bet you can count on support from the Planetary Society in that funding request to extend that mission.
All right, I've got you on tape.
As if I'm in charge, but I'll talk to the science guy about it. How's that?
Right.
When on the evening that people are watching this, I probably have Bonnie from your science team sitting right next to me. Just one of the great scientists that you've got that are so looking forward to this data from New Horizons. Talk about the team that you've pulled together.
Well, I'm just so proud of this team, from the flight controllers and the engineers to the public outreach people, and of course the science team, from the senior members like Bonnie, who'll be speaking to you. She's a JPLer who's been on Voyager, Cassini, Galileo, all the great missions. She's an expert in the study of planetary surfaces using a technique called photometry. To Hal Weaver, who's our senior project scientist. He's at the Johns Hopkins Applied Physics Lab, actually a expert in comets and the outer solar system. But we've got experts in imaging science, in composition spectroscopy, in plasma science, in atmospheric science, geology, geomorphology, geophysics, and I could go on. This is an extremely strong team comprised of about 30 scientists from around the United States and their postdocs, and in some cases, their graduate students.
And no doubt thousands of other scientists and tens of millions of the rest of us waiting for those exciting moments to come from this mission. Before I let you go, one comment, please, a status report on Rosetta, which you are the PI for one of the instruments.
I'll do that. And then I want to show you a little something I've got along that people might enjoy. I just want to hold up for the camera.
Yeah.
But yeah, Rosetta's going very, very well. As you know, the Philae lander just completed its primary mission. We're hoping it revives itself when the landing site gets back in sunlight. But now the big orbiter, which is really a Cassini-class orbiter, studying this comet with a 100-foot wingspan, 13 instruments on board, 3 of which are U.S. instruments, is performing just spectacularly, orbiting at close range, staying with the comet, and for the first time, watching the time evolution as a comet turns on its surface evolves, it goes right through perihelion closest to the sun. It's a great chance to really learn how comets work in a detail that flybys can never give you because they don't stick around long enough. Rosetta is just a dreamboat of a mission to be a part of, just like New Horizons. And I can tell you the science team here is reporting result after result after result coming from those orbiter instruments. And we haven't even really got to the good parts yet.
All right, Alan, time for the big finish. What did you want to show us?
Well, I just want to tell you that we have the coolest bumper sticker.
Hold it up
in
a
the
little bit
space
higher.
business.
Hold it. Yeah, there you a little high.
How's
There you
that?
go.
There you go. In my view, this is the best bumper sticker going.
I love it.
My other vehicle's on its way to Pluto. How many people can say that?
I think only one or two. Well, one, the one I'm talking to right now, is the best qualified. Listen, we stole your title for this webcast. I don't know if I owe you royalties about waking up on Pluto's doorstep, but did anybody consider knocking on Pluto's door?
Actually, that's been suggested. We have a different wake-up song that'll be announced this weekend, and I think people are going to like it a lot, but that's a suggestion that's been made. So stay tuned. We'll be announcing our wake-up song this weekend, and then hopefully your listeners and everybody else will like it so much, they'll start posting it to Facebook and tweeting it. We think it's a great lyric and a great song, specially produced by the singer for New Horizons and for this wake up on the frontier of the solar system.
Lots of great public outreach in this mission as well. Alan, thanks so much. I look forward to getting you back on Planetary Radio. Best of luck in 2 days. I have total confidence, and we'll be watching from Planetary Society headquarters.
Thank you, Matt.
And we are back live at Planetary Society headquarters after that conversation of a couple of days ago with Alan Stern. Yeah, you can take those off until we get ready to talk to Felicia, who's going to be joining us. Whoops, I got to turn off some video here. Sorry about that. We'll be picking up Felicia Sanders in just a moment or two. Bonnie, that's the first time you saw that conversation with Alan. And did you have any comment?
I think it's a great summary. I think that, Alan is a very inspiring person, and he just got into the excitement that we're all feeling. It's like kind of, we're going to see a little bit more every day, just we'll be speculating, and then, we'll know whether we're right or wrong, and we'll come up with new ideas. I mean, science is like that, I mean, just in a few really months, we are going to learn more about Pluto than we've learned in, since it was discovered in 1930. So it's just the excitement is really building. That's what I felt.
Truly amazing. How'd you like that abbreviation, BTH?
Yeah, that's pretty, we're going to get a lot better than Hubble,
yeah.
Really, a lot better.
We are now about to go, as I said, to Felicia Sanders. You might want to put the world's ugliest headphones back on. And I better put my microphone back on. That'll help, won't it? There we go. Sorry about that. As we prepare to talk to Felicia, let me bring something else up here, and that is how you can, if this is going to work, we are taking questions. If you include hashtag AskMatt, as you should see on your screen right now, I'll be, if this works, monitoring my iPad, and we will try and get some of your questions to Bonnie, and perhaps a little bit later this evening to Hal Weaver, the New Horizons project scientist. So we'll leave that up for a moment or two, and I'm going to try and turn her up here, right on this channel on the mixer, and say hello to Felicia. Felicia, are you there?
Deep Space Network provides spacecraft controllers.
Oh, for some reason, we lost audio there. And I think there might have been a software problem. And so I do apologize. I hope a lot of you stuck with us there. I think it's now working again. Just a problem we didn't run into when we ran the test this evening. So Felicia, sadly, we were talking to you, and apparently they were watching us, but nobody was out there hearing what we had to say. So I'm glad it's been fixed. But let me just reintroduce you. We do have Felicia coming in, and I will put her picture up right now. Felicia is a mission interface manager for the Deep Space Network, or DSN. She worked on the Deep Impact mission. She was part of the team that landed Curiosity on Mars 2 years ago. And so, Felicia, I apologize for that problem, but welcome once again to the webcast. And her
My pleasure.
There you are. It froze up there for a moment. Listen, there may be a few people in our audience, I'll bet very few, who are not really familiar with the miracle that is the Deep Space Network. Can you give us a little bit of background?
Certainly. The Deep Space Network is NASA's international array of giant radio antennas. The array of radio antennas are located at 3 facilities around.
We got a freeze there. We were having some trouble with the connection from the home that Felicia's at. It should be back in a moment. Hey, Felicia, we lost you there for just a second.
These deep space communication complexes are located near Barstow, California, near Madrid, Spain, as well as near Canberra, Australia. The DSN provides the crucial communications between Earth and spacecraft that have been launched into deep space. Without the DSN, there would be no way to communicate with the spacecraft. The DSN provides spacecraft controllers and scientists on Earth with the ability to send commands to the spacecraft as well as receive telemetry or data from that spacecraft. The data received from the spacecraft provides crucial information to our instrument controllers as well as scientists. The deep space plays a crucial part in facilitating our understanding of the universe, our solar system, and ultimately our place within both.
So tell us, what is it that a mission interface manager does?
As a mission interface manager for the Deep Space Network, my job is to act as the interface between the spacecraft project and the Deep Space Network. As the Deep Space...
Another quick freeze here.
It's my responsibility to manage all the DSN work that is involved to ensure that the spacecraft telecommunication system is well understood. If a new capability needs to be implemented within the DSN, it is my responsibility that those requirements are fully understood, implemented within the DSN, and tested prior to launch day. The work that I do is essential to ensuring that the Deep Space Network can successfully communicate with a spacecraft such as New Horizons once it's landed. I would be remiss if I did not mention that there are many, many talented engineers performing the work in support of the Deep Space Network at the Jet Propulsion Laboratory, as well as at the communication complexes all around the world.
Bonnie, you could have some pretty great spacecraft, but without the DSN, you wouldn't really have much to do, would you?
It's a key. It's a key. I mean, they really perform magic. It's just amazing what they do. I mean, we wouldn't have anything without the DSN.
Yeah. Felicia, you've got a spacecraft now that is, let's see, 31 times as far from the sun as our planet is. Call it 30 billion miles or 47 billion kilometers. Voyager 1 and 2 even farther away. You got pretty tiny transmitters on those spacecraft, don't you?
Definitely. I'm not really involved in all of the particulars with the spacecraft itself. I'm more involved with the ground operations and, you know, the way we acquire those signals and communicate to the spacecraft.
So what kind of signal reaches Earth? How strong is it by the time it crosses that huge expanse?
So approximately negative 167.9 decibel milliwatts is the signal strength that we're receiving at the 70-meter antenna located in Canberra, Australia.
And it is the antenna in Canberra that will be delivering this message to us this evening. Okay.
Yes.
Very good. We are getting questions to ask Matt. Again, we apologize for the lack of audio when we came back out of Alan Stern's the video interview that we recorded with him a couple of days ago. Felicia Sanders has joined us from the Deep Space Network, although today she is at the home of a relative where they're celebrating a birthday party, and we'll probably continue to have some of those dropouts some bandwidth problems happening with that. If you do have a question for us, I will pop it up here again. You want to tweet to the hashtag AskMatt. And we will get to a few of these questions. In fact, we'll try and do that now. I don't have word yet. We are in that window when we may be getting the message from New Horizons that it has indeed awoken for the 19th time and is ready to begin the most important part of its mission. So let me pull that back out of there. And Bonnie, I'm going to turn back to you for a second.
Okay.
We got a science question here. And this comes from an Amy Crawford. Scientists have said they think Pluto has liquid water. What would be the heat source for water in a liquid state on Pluto?
Yeah, there are actually a couple sources. The first thing is radioactive heating. You know, Pluto is more dense than water ice. Water ice has a density of about 1, gram per cubic centimeter. But Pluto is more like 2 grams per cubic centimeter. So that, by comparison, Earth is 5 grams per cubic centimeter. So it's not as dense as the Earth, but that means it has some rock in the interior. And combined with the rock are things like uranium that actually create heat as they decay. So that's the first source. The other source is just the pressure of the material. In the Earth, as you go down towards the center of the Earth, it gets hotter. Pluto is the same way. It's just the pressure of the material on top creating heat. So those would be the two sources. Also, there is some heat left over from when it formed. When a body comes together and what scientists call accrete, there's some heat produced. So those are the three major sources, and it's all a model. We're not really sure. But there are some modelers, some interior scientists that think that there may be a liquid ocean underneath the surface of Pluto. There wouldn't be anything on the surface, any liquid water you could see, because it would freeze really fast. There is water on the surface, but it's all frozen. It's like a frozen rock solid.
I have a big announcement to make. The tweets that I am getting seem to indicate that indeed that signal has been received from New Horizons that tells us it is awake and ready for its encounter with Pluto. So
Great.
Go
Yay.
New Horizons. Your network is doing its job, Felicia. Felicia, why might there have been a delay in getting this? We were told that it might have been down toward the horizon in Australia.
Well, it certainly has to. The spacecraft has to be in view of the antenna. So if it takes a little bit longer for that spacecraft to come into view of the antenna, then it could be delayed by a bit of time.
Okay, we're back. We're going to be saying goodbye to Felicia in just a couple of moments here, and then in about 5 minutes, we're going to try and place a call to Hal Weaver, the New Horizons project scientist, who is at the center of things at the Mission Operations Center at the Johns Hopkins University Applied Physics Lab. I think I'm going to scan the other questions here. We still have stuff coming in. Here's one from somebody with the interesting pseudonym, Atomic Elbow. I can't figure that out.
Okay.
If the atmospheric pressure on Pluto has doubled in the past 15 years, what is thought to be the cause of that?
Seasonal change. Pluto is inclined, just like the Earth is. We know that on the Earth, the thing that causes the seasons is the fact that the Earth is tilted. Well, Pluto is also tilted. In fact, it's tilted even more. So just like the Earth, Pluto goes through seasons, and what makes it even worse is Pluto's orbit is kind of oblong. It goes between 30 times the distance between the Earth and the Sun to 50. So it has super seasons. And what happens is it has polar caps that we think, just like on the Earth, sublimate and then recondense. So when the polar cap, Pluto went through perihelion, so its polar cap sublimated, and that produced gaseous nitrogen that was put into the atmosphere and caused the atmosphere to increase in pressure. It's actually doubled in the last 15 years.
Well, Atomic Elbow, I hope that answers your question, and I love your Twitter handle. Felicia, we are going to say goodbye to you, but before we do that, tell me, what happens with your job now as much more data starts to flow from New Horizons?
Well, there's still a lot of work to do. We need to make sure that our encounter is successful this coming spring. So there's lots of planning and preparations to ensure that the Deep Space Network is in place and ready to support New Horizons.
All right, Felicia, we're going to let you get back to your birthday party, and just thank you very much for joining us on this webcast to celebrate this milestone by the New Horizons mission. Again, thank you very much.
Congratulations.
Thank you.
Okay, let me switch back here to the studio at Planetary Society headquarters. And in a couple of minutes here, we'll be placing that call to Hal Weaver, who is the project scientist for New Horizons. Let me see if I can come up with another question here, Bonnie, for you.
Great.
While I set up that Skype call. Let's see. A lot of people commenting on the fact that we didn't have sound there for a little bit. Looking for a really good one here. Boy, lots and lots of people who noticed we had a problem. I know that there were some down this way. Here's a great one from Richard, looks like Mortal. Is it possible that New Horizons could reveal something about Pluto that would make scientists like yourself reconsider its status as a planet?
That's a really good question. You know, when you go to these new objects, you are more surprised than you can ever imagine. I mean, personally, you know, I was very disappointed that Pluto was demoted, and I didn't see any reason why we should. I mean, Pluto has 5 moons. It has an atmosphere. To me, it's way more than something that's not a planet. I mean, it still is a dwarf planet. But, you know, we don't control what is a planet or not. You know, scientists that are working on the mission, it's the International Astronomical Union that controls it. And quite frankly, you know, we don't think it's that important, whether we call it a planet or a dwarf planet or, you know, a Kuiper Belt object. We're just interested in the science and the interesting object and the fascinating things we're going to find. That's what we're more focused on, you know, whether it's a planet or not, quite frankly.
I can't remember if, I think that I talked about this with Alan in my conversation with him, but we have a question from Lorena about the time lapse of communication between New Horizons and Earth. Mm-hmm. I think is it 4.5 hours now?
Yeah. It's quite a distance, and I'm kind of used to that because I actually observe Pluto through a telescope. In fact, we're just trying to understand it, and you have to correct for that time also when you observe it, you know, as a telescope, through the telescope. It's actually in a different position, you know, when you observed it 4.5 hours ago.
So, of course, New Horizons sent that signal that it was awake and ready to go 4.5 hours ago.
Exactly, yeah.
We are just about a minute away, I think maybe a couple of minutes, from making that call to Hal Weaver at the Mission Operations Center at the Applied Physics Lab. Now, here is one from Heather Leet. Within the realm of reasonable expectations, what would be the most unexpected finding on Pluto? I mean, I guess little green men, I would think. But I mean, what do you not really expect? But what would you hope for?
Well, I would like to see a big plume like we see on Enceladus, which is this fascinating moon of Saturn that's kind of a winter wonder world, because this plume spews out all this ice, which immediately, water ice that immediately freezes, and it basically snows back onto the planet. I mean, I think it's just fascinating, and I'd like to see that on Pluto, but it probably isn't going to be there because you have to have a lot of tidal heating or some other source of heat. So we might see some little tiny plumes, but I would really like to see a big giant plume, a super geyser, that similar to the one we saw in Enceladus. That would be really fun.
Let me throw one more at you from our audience. It's Chris Boswell with the Rosetta and New Horizons missions. How much more might we learn about the formation of the solar system?
Well, these are objects that were left over from the formation of the solar system, comets and Kuiper Belt objects, and asteroids as well. So I think, for example, if we can find out if there is a water ice mantle underneath, you know, the liquid water, that'll tell us that there's been a lot of alteration on these bodies. Because with water, you have a lot of chemical reactions. So that'll be, we're not really sure if they're primitive or they've been through a lot of processing. So I think that'll be one thing that, you know, if there is water ice, it probably has differentiated, and actually it's not primitive. It went through some activity after it was formed. It hasn't really been inert. So I think that the other thing is just the composition. You know, Alan talked about these Kuiper Belt objects that are much further out than Pluto we're going to look at. If we can compare that with Pluto, we're basically mapping out what the cloud of dust and gas from which the solar system formed. We're mapping out the composition. We can understand the temperature and pressure conditions. It's this cloud of interstellar dust from which we were all formed. We're going to find out about that.
Great. I think we're ready to try and place a call now to Hal Weaver. So bear with me as I try to bring him up on Skype.
Oh, there he is.
And there he is.
Yeah.
He hasn't answered
Hal.
yet. Oh, he's not up yet.
Okay, all right.
With any luck, we'll have him here in a moment or two. I'll remind you that you're watching a special live webcast from Planetary Society headquarters, marking a major milestone for the New Horizons mission, which is closing in on Pluto and its neighbors. And it looks like the call did not go through. It wants to know if I want to leave it.
The
Oh, wait a
person
minute.
whom you're trying to reach is currently unavailable.
Well, we all know who she is. I guess it does say that Hal is offline. We might have to try and call his phone instead. So bear with us as we set up to do that if we need to. I'm going to try and make one more call to him. Normally, the firewall at the APL blocks Skype calls, and they said that they had given special dispensation to Hal so that we would be able to talk to him this evening via Skype. If it doesn't work, we do have a backup, his cell phone. So well, it doesn't look like it's going to go through. Too bad. Okay, Bonnie, I'm going to look for another question that we can ask you, and then
Okay.
I will plug in the phone number there,
Okay.
and we'll talk to Hal that way with any luck. Here's an interesting question from George Molnar. When will New Horizons, when will the team feel comfortable with the trajectory, avoiding anything that it might run into out at Pluto? I know this has been a real
Yeah.
concern.
Yeah, that is a big concern. You know, after we found all these moons, we thought that maybe there's a lot of little moons and some dust in there. So we feel a lot more confident now when we do have a safe bailout trajectory in case we find, particles when we get close in rather. But a lot of modeling, my colleague Mark Showalter and other people from JPL and other places have been doing modeling of what would happen with dust if it were there. Most of it would be cleared out by the moons, and we're pretty confident that we'll be okay, but not 100%. We're maybe 99%. So when we get closer up and if we see any dust there in the spacecraft trajectory, we will make alterations to the path of
All
the
right,
spacecraft.
fingers crossed. Talk about what Alan spoke a little bit about in that recorded conversation, and that is the next target, where New Horizons will be going next, and how Pluto is going to help us get there.
Yeah, well, Pluto is kind of tiny, so it isn't going to give that much of a gravity assist. We're going to have to use the little precious amount of fuel we have on board to get to those objects. And, that was a challenge in trying to find objects, because they have to be, there thousands of, that we know of Kuiper Belt objects. There's probably, a million or more that we haven't discovered. But to get to those objects, we will have to use fuel in the spacecraft, and there's a very narrow cone of area that is actually that we were able to get to. So it's mainly just fuel that we're going to be using to get there.
I'm making one more attempt. You may have heard the Skype noise there a moment ago to reach Hal where we would be able to see him, but it does not look like it's going to work. I think something must have happened that maybe somebody hooked up the firewall again, unfortunately. So let me hang this up, and I'm going to attempt to make that phone call by dialing it in right now. Bonnie, if there's anything else that you would like to tell us about what you hope New Horizons will do, I have another good question for you. Could you talk a little bit about the instruments and why they are such a good suite of ways for us to learn about this body?
Well, we kind of cover all wavelengths. You might remember on Voyager, we basically had a camera and an infrared detector, but we couldn't tell the composition. But we have instruments on New Horizons where not only can we take pretty pictures and take pretty color pictures at the 70 to 90 meter resolution that Ellen was talking about, but we also have spectrometers. That is, we can look in the infrared and the ultraviolet portions of the spectrum to get the composition, because that's where all this compositional information is. From looking at a camera, you can't really tell what it's made of. So that's a big step for us. And we also have a lot of instruments, fields and particles instruments, that will measure the particle environment, the solar wind and that sort of thing. We also have what I think is one of the most amazing instruments is the student dust counter. It's this dust detector, and it's been on. It's been taking data that was built entirely by students from the University of Colorado, and it's been managed. They had a faculty advisor, but they built it and managed this instrument. Quite amazing. And we also, of course, will use the antenna as a radio detector in order to take occultations and that sort of thing, measure the atmosphere.
Which many other spacecraft, Cassini has done that and so on.
Right, yes, we do that. So it's very sophisticated. It's very well thought out. Good compliment.
I'm going to try making this phone call to Hal and see if we can pick him up, at least for a couple of minutes as we close in on the end of the program here, because we will be closing out at 10 o'clock. Well, the phone is ringing. That's a good sign. Hello, Hal.
Hello.
Hal?
Hello.
Hal, can you hear me?
Hey,
Hal? Hello, Hal.
we're still waiting.
Apparently he cannot hear me. I'm not sure why. Hal, you're not able to hear me? It's not going through. We can hear him. I have no idea. I'm going to hang up and try making that call again, which hopefully I can do pretty quickly here. Bonnie, what will you be up to over the coming weeks as we wait for New Horizons to get to where it does have that better view than we can currently get from Earth?
Well, you know, I've been looking at a lot of ground-based data on Pluto, trying to track seasonal change. So I'm still working on that. And the other thing is we have to get a lot of science models up and running. You know, we have to be ready when we get that data. So I'll be doing a lot of modeling, same models that I've used in the Cassini data, getting those all up and running and ready to go and improving them and modifying them. And also we're starting to get a little trickle of data down. We can resolve Pluto and Charon in the LORRI camera, the high resolution camera we have. So starting to look at that data, and there's really a lot of work to do coming up into the encounter.
You can tell the phone is ringing once again. We'll see if Hal can hear us this time. I'm hoping that was just a glitch with Skype because we have the same setup we did with Felicia. So let's see if he picks up. I think he may still be hoping that we're going to talk to him on Skype. He may not know that we can't get through. Hello, Hal. Can you hear me this time?
Hi. I'm not
Hal,
available
can you
right
hear
now.
me this
If you
time?
leave your name, number, and a brief message, I'll try to get back to you as soon as possible.
Shall we leave him a message? Say hi to Hal.
Please record your
Okay.
message.
Yeah, we could.
When you have finished recording, you may hang up or press 1 for more options.
Bonnie?
Okay, so Al, this is Bonnie. Congratulations. We're here in the studio at the Planetary Society, just talking about all the wonderful things that the mission will be doing, and we just are so happy that it's out of hibernation for the last time, and it's just wonderful that it happened, and congratulations.
And congratulations from all of us here at the Planetary Society as well, Hal. And I hope we can get you maybe on Planetary Radio sometime soon. Okay, I'm going to try one more time to reach him via Skype the way we had planned. And it worked fine. We're doing a little test earlier. We'll make this one more shot. And then it's just about going to be time for us to wrap up, Bonnie.
Okay.
So again, New Horizons, that signal has been received. It has told us that New Horizons is awake and ready for its encounter with Pluto, which will climax on July 14th at closest approach. Nope, it's not going to work, unfortunately. No, I think they must
The
have...
person whom you're trying to reach.
Yes, we know about that. Oh, well, Bonnie, it's you and me for the duration, I'm afraid. We are just about ready to close out. Do you have anything that you would like to say to the people watching tonight and everybody else out there who is actually thrilled that we are going to be reaching Pluto?
Well, I just wanted to encourage people to go to the website. If you just Google, APL New Horizons or just New Horizons Pluto, you'll come to a website. And I'd really like people to follow the mission. And Alan sends out new blogs and announcements weekly. And to be part of the whole excitement, this is the heritage of the American people. We are not doing this for ourselves. We are doing it for you. And we are doing it because it benefits our country. The new technologies, the types of discoveries that not only New Horizons, but the space program has made. It's just, I was talking to this friend of mine, a colleague at JPL, who actually works on life on Mars. He's an astrobiologist, and he was telling me that he's working on some stuff to sterilize his lab, because he looks at how these microbes can live in very inclement environments, very nasty environments. And actually, the Department of Health has contacted him because the types of techniques he uses to sterilize his instruments, they want to use for research on dangerous emerging diseases. Okay, so you never know where you're going to discover something, and space science and the exploration of the solar system is it's free form. We do basic research, we go to new worlds, we never know what we're going to see and how that is going to benefit our country. We are so grateful that the taxpayers have supported us, and we do this for you. We want to give back, we want you to follow it. We put all the data in the Planetary data system where you can look at it. If you go to the website, there's a lot of first look data, but every single piece of data will be stored for you to look at, because it's our heritage as Americans and leading scientific discovery and innovation and technology. It's just really one of the things that makes our country great. That's how I feel about it, and we're just so grateful for the support.
With just a few seconds left, do you have any doubt that something that we find out there is going to be a surprise?
We have been surprised every single time we have gone to a new object, and we've been surprised beyond what we could ever imagine. So I would be very surprised if there were no surprises.
Well, we have a surprise for the close of our program, so stay tuned. You heard Alan talk about it during that conversation, but we are basically out of time for this evening's special coverage. I'm sorry that we couldn't bring Hal Weaver in, but I think we will try and get him on Planetary Radio pretty soon. I do want to thank our guest, Felicia Sanders of the Deep Space Network, Hal Weaver, who was standing by for us, New Horizons Principal Investigator Alan Stern, of course, and my comrade here at Planetary Society Headquarters, JPL's Bonnie Barati. I also want to thank Michael Buckley at the JHU Applied Physics Lab for his invaluable help with everything that we've been up to, along with Al Banji at JPL, because he was the one who steered us to Felicia Sanders. Please keep an eye on planetary.org for ongoing coverage of this and so many other missions, along with all of our great social media efforts, some of which probably some of you have been following this evening as well. I think you can count on the Society providing special coverage of Closest Approach on July 14th, 2015. That ought to be quite a party. And I hope that you'll join me weekly for Planetary Radio. You can hear us on iTunes, Stitcher, Sirius XM, about 120 public radio stations out there, and of course at planetary.org. Just one more thing, as I promised to share with you. You heard Alan Stern mention a special song recorded just for this occasion. Well, we've got that song for you. I had to keep it embargoed for a couple of days, but Alan was nice enough to provide it. You Trekkies out there are going to recognize it. It is introduced and performed by Russell Watson. So from Planetary Society Headquarters in Pasadena, California, this is Matt Kaplan wishing you clear skies. Here is Faith of the Heart. As soon as I can bring it up.
Well, hello there. Greetings, New Horizons. This is Russell Watson. It's been a long road, very long road, nearly 3 billion miles, I can hardly believe it myself, and 9 years since the launch. And your time is finally here. I've played this song to wake astronauts in orbit around the Earth, but never for a NASA spacecraft waking on its voyage to the farthest reaches of the solar system. It will be cold dark at Pluto. But you won't be alone. You carry the dreams of explorers everywhere. I have faith that you'll inspire us with views of a new world like we've never seen before, while blazing the path for NASA and their missions to follow you through the solar system and beyond. New horizons, your adventure, Pluto awaits. Safe travels. God bless.
It's been a long road, and getting from there to here, it's been a